from the monitor because I can't get the board to work. So it is what it is. Still record everything, still gonna write in the OneNote. All the extras will still be there. I just won't be able to stand up and jump around and walk around and, just stuck at the desk for right now. I know, I'm disappointed too. All right. So what we're going to be talking about today is we're going to start talking about the graphs and the equations of graphs for sine, cosine, and tangent functions. So we're going to be looking at really two primary skills in this chapter. We're going to be looking at taking an equation and turning that into a graph, and then taking a graph, turning that into an equation, and then a variation of that will just take a little bit of information from the graph and turn that into an equation. So those are like really the three types of questions you're going to see here. That'll be the only three types of questions you'll see, other than like some vocab or applied vocab stuff. But those are the three main problems. Everybody okay with that? All right. First thing we want to do, what you're looking at here is the graph of the sine function. And you're looking at this and asking yourself, where in God's name is that coming from? How the heck are you making this thing? Essentially, all we're doing here is we're going to be taking the unit circle and plotting the points. I know, me too. So please take out your unit circle for me, and we're going to kind of talk through how this process works together to get you a feel for what we're doing, and then how we're going to make the process simpler in general. But we're going to start with doing it the hard way so you can appreciate what we're doing when we simplify this process down. Everybody good with that plan? Okay. Everybody's found their unit circle. There should be one that I handed out to every single one of you guys. Yeah, I can stall and tap dance here for a minute while you look.
I found it.
Fantastic. Thank you for the update. So, what you're looking at when we look at this graph, again, the x-axis is going to be the angle, and the y-axis would be like the y-coordinate from our unit circle. So if I look at my unit circle and I find the angle 0 degrees, look on your unit circle, find the angle 0 degrees, and then read to me the y-coordinate there. That's 0, right? So that would mean we'd be plotting the point 0, 0, because we're plotting angle, y-coordinate. Why am I using the y-coordinate from the unit circle?
Because sin is y.
Excellent. That's 100% because sine x is the y-coordinate on the unit circle. Somebody studied. That's why.
Yes.
All right. Next, let's look at, if I look at the x-axis, how I've labeled this. I've labeled everything by quarters of pi. I have 0.25 pi, 0.5 pi, 7.5 pi, etc. So on my unit circle, I'm going to go to 0.25 pi, or as a fraction, pi over 4. So find pi over 4 on your unit circle. What is the y-coordinate there? Okay, great. Root 2 over 2. Now, if I type root 2 over 2 onto my calculator, I'm going to get the decimal 0.707. So there I'm plotting pi over 4. and then 0.707. Next, let's go to 0.5 pi, which as a fraction is pi over 2. What is the y-coordinate at pi over 2? It's 1, thank you. I'd love for all of you guys to be answering on this, just so I can see you practicing using your unit circle. Does everybody see what's happening here? If I go to 0.75 pi, that's 3 pi over 4. Find 3 pi over 4 on your unit circle and read me the y-coordinate.
Radical 2 over 2.
Also root 2 over 2, which again as a decimal is 0.707. Everybody's okay with this?
Yeah.
Okay. The next spot I need is pi. Find the angle pi on your unit circle and read me the value for sine.
0.
0. Does everybody feel okay with the process that I'm using to graph the sine function? So if I continue, I get negative pi over, or root 2 over 2, and then negative 1, and then negative root 2 over 2, and back to 0. And if I keep going around my unit circle and using those same spots, it's just going to keep repeating the graph over and over and over again, right? Notice that this graph is just going to repeat itself as I go around the unit circle a second time, and a third time, and a fourth time. I'm just going to get this same wave going on over and over and over again, right? So there's lots of different terminology you can use for a function that repeats itself like this. You can call it a cyclic function because it just recycles itself over and over and over again. Sometimes we'll call it a harmonic function. It means the same thing. You could call it a wave function because it looks like a wave. All these could be used interchangeably to describe that graph. Or the word we're going to use in class is any graph that kind of repeats itself like this, we're going to call a sinusoid. I know. So the spelling of that is sinusoid, sinusoid. And that just describes that type of graph that repeats itself over and over again. Everybody's okay? Okay. For a graph like that, we're going to have several key features. And these key features I'm going to describe to you visually because the words I feel like don't make as much sense as the visual. So I'm going to draw what the thing is or where it is or what I'm talking about. And then you guys can, and I'll talk through what the definition means, but I probably won't write it down because I think it'll be more meaningful to just kind of look at the picture. So the first key feature that all sinusoids have is something called a midline. So the midline divides the graph in half vertically. So half of the graph should be above the midline and half of the graph should be below the midline. If I look at this graph, what horizontal line is going to divide the graph in half? The x-axis, right? AKA the line y equals 0. Everybody's okay there? So I'm going to color code this vocab so as I draw it in there, it'll be, and you look at it later, it's color coded. So the midline is the green thing. These graphs all have amplitudes. And amplitude is just how high or the distance from the midline to the highest or lowest point on the graph. So like all of these would represent an amplitude. Is everybody okay with that? Yeah, it's just the distance between a highest or lowest point on the graph and the midline. So that's a length, right? So it's just going to be like each one of these distances is like an amplitude. Everybody feel good there? So again, I don't have to do that for every one of them, but how many places could I find the amplitude on my graph? Infinitely many of them, right? Yeah, I keep having these high and low points, and all I have to do is look at that distance one time to get the amplitude, because it'll be the same at all those spots. Does everybody feel good so far? This is me trying to slow down and make sure everybody's like kind of on the same page, because it seemed like last chapter maybe things got away from us a little bit. So this is me trying to like circle the wagons and make sure we're a little bit more all at the same spot. The next thing we're going to talk about is the period. I spelled sinusoid wrong, huh? Should be like the same as period, I think. No? I don't know. Does that look wrong? Did I spell period wrong? Yeah, I don't know, man. Like, it's all confused. Spelling's hard, guys.
How you spell steroid?
All right. We'll go with it. This is me going, I don't really care about spelling. I think it's a way harder than math is. Anyway, so you notice that we talked about this graph, how it repeats over and over and over again. So when we talk about one period of the graph, we're talking about the length, so a horizontal distance of that longest non-repeating segment of our graph. So one non-repeating segment of our graph could be that, right, where we start at the midline, we do an up, we do a down, and then we end back at the midline, where we'd be starting another up section, right? So that horizontal distance is going to be the one period. That's a great question, Addie. No, your period could start, from like crest to crest, or from trough to trough, right? Or somewhere in some other spot. Does that feel okay? Oh, and of course. So again, like you have periods all over the place, right? There's infinitely many of them. Any non-repeating segment, whether you want to start at the midline or at a crest or a trough or some other spot. I don't know why you'd want to start at another spot, but you could. Does that feel okay there? And then my last guy is a frequency, and this one I'm actually going to describe in words. This will be the only one I describe in words because there's not a good visual analog to it. Because the frequency is just the number of periods per unit length. So it's like, how many periods do I get in one unit of my x-axis? That's kind of what we're describing. Everybody's okay? Okay. So I'm going to scoot over here a little bit. Last year, when you guys talked about graphing functions, specifically maybe like a quadratic, you guys talked about parent functions and resultant functions. Does that sound familiar? Yes or no? I'm trying to connect this with something that I hope that you recognize. If that's a no, then I have to back up and start further back. If it's a yes, I don't have to back up as much. I'll give you a little bit and then we'll just kind of go. But I need some feedback from you if you recognize this verbiage or not. Parent function, resultant function, when talking about graphs. So last year you would have talked about when you graphed quadratics, your parent function would have been like y equals x squared, right? And you say, okay, well, any transformation of that parent function could be written in the form a times x minus h quantity squared plus k, right? This is our resultant function. And in Algebra 2, you would call this like vertex form, right? Everybody's okay with that? And the idea is you can take some point on the parent function, some xy, and you can transform it to some point on the resultant function by taking that x coordinate and adding h to it, and taking your y coordinate and multiplying it by a, and then adding k to it. Right? You guys kind of remember doing that? So if my parent function had the point, well, let's write out an example. So let's say we had y equals 2x minus 1 squared plus 3. My a was 2, my h was 1, and my k was 3. So the map that I would write then would have been x plus 1, 2y plus 3. So if I wanted to take some point from my parent function like 1, 1, I would just plug the 1's in for x's and the 2's in for y's, and I get a new point that I could plot on my parent function. You guys kind of remember doing something like that in your Algebra 2 class? We're going to use the same method when we start graphing here. But before we do that, I want to just describe what that general form of a sinusoid looks like and how the coefficients relate to the midline, the period, the frequency, the amplitude that we had just discussed earlier. Is everybody okay? Feel reasonably connected now, grounded to something else you already remember doing? So we have our parent functions are going to just be y equals sine x or y equals cosine x. Everybody's okay with that? So those are like our parent function. Actually, I'm going to scoot this a little bit over. I'm going to make a little bit more space here. Our resultant function So notice that I've picked up a new coefficient, right? I have this 1 over c that wasn't a part of our resultant function, our general function, or whatever for our quadratics that you had seen before. We'll talk about what that does in a moment.
So this is all protein scale?
Yes, that is what we're talking about right now. So what I want to do here is I want to relate now those key features to the coefficients in our resultant function, our a, c, h, and k. So the amplitude is just going to equal the absolute value of A. So now if I have the equation, I can find the amplitude without having to look at a graph at all, right? Or if I have the graph, I can figure out what are the two possibilities for A, either positive or negative, just by looking at that distance from the highest point back to the midline. ML stands for midline. The midline is y equals k. So loud. So again, I can get the midline just from looking at the equation, or if I'm given the picture of the graph, I can use the midline that I can see with my eyes to figure out the k coefficient for my formula. Is everybody okay with that idea? We'll do some examples in just a moment. The period is 2 pi times the absolute value of c. Again, I can get the period just from the formula, or if I'm looking at the graph, I can use the length of the period to find potential values for c, like positive or negative of some number. Does everybody feel okay so far? Okay. And then the frequency is going to be 1 over the period. Does everybody feel okay there? Again, the frequency and the period are related in that they are reciprocals of one another. Typically, it's going to be hard to look at a graph and pull the frequency from the picture. That's usually not very easy to do. But if I have the period, that's relatively easy to see in the picture. The frequency is just the reciprocal of it. It's like, if I have one, I can get the other pretty easily. The period's typically much easier to come up with visually than the frequency is. So frequency, not that terribly useful to us, but in real world situations, the frequency is often really useful to us, where like an RPM is essentially like a frequency measurement. Everybody so far so good? Okay. Now these values that we've just written down, you're going to use to do probably every single type of homework problem throughout the entirety of this chapter, you would definitely want to have this information on any note card going into a test. This information right here is going to be like super duper important. This would be something you want to make sure is written down, or you know where to get it from. If you're building a note card like as we go, or a rough draft of a note card as we go, this would be something to put on it. We talked about that being a potential good idea. In addition, I would probably have the picture definitions for, midline, amplitude, and period as well. That would be, I think, also pretty helpful, come test or quiz time, if you have the picture definitions for those guys written down as well. Yes?
This is gonna stay in the OneNote, right?
The stuff I write in the OneNote stays there. It'll be, like if you're looking at the content library, you'll see it updating kind of live as I go. I don't delete it afterwards, so it's always there for you.
Okay.
So again, if you're not, like, I do better processing sitting and listening than I do trying to write, because I write down and my ears turn off and I don't actually hear anything. I get that's totally fine. This will always be here for you. Gabby?
I like the note card, you know, smooth stuff off, and that's what it's all. Written down.
You have to write it by hand.
Okay.
So you can't print it,
Okay.
because I'm afraid of somebody bringing in a magnifying glass and a 0.5 font, and you've printed every single thing, like the entire lesson for the chapter, which I wouldn't put it past somebody giving it a shot. So my rule is just you have to handwrite it. If you can write it as small as you want, as long as it's handwritten, you have to be able to read it. I don't think anybody can write. I mean, I've seen some extraordinarily neat and small penmanship before, but that feels like a fair bar as opposed to allowing people to print some like tiny microscopic thing where they need a magnifying glass to read it. Gabby's like, I wasn't even thinking of doing that, but like, I get your point, I guess. All right. So let's do a couple of examples, just using this information that we have right here. Sound good? All right. So I'm going to write down a function let's pick a different number. Let's do that. And we're going to start by identifying the values for A, C, H, and K, and then find the values for the amplitude, the midline, the period, and the frequency. Yes? Sure. Does everybody feel okay with the plan here? This first skill of getting the equation and pulling the values of A, C, H, and K from the equation is the core skill for this chapter. If you struggle to do this, you're going to make the same set of mistakes over and over and over again, and it's just going to beat you up all the time. This is a skill that you need to get straight. We're going to do like several examples here of doing this, so we're going to get a lot of practice right now. We'll do this first one together, and then I'll call on some people to help me answer the remaining parts for the next ones. Okie doke. So when I'm doing this, I like to start by just kind of writing that general form above so I can see things matching up. Grace? Sure. So if I look right away I can see that looks like my A, and that looks like my K, right? Everybody's good with that? Those guys are going to be the no problemos. The place where students have a rough time is pulling the C and the H. And we'll explain why here in a second. So what I'm going to do here to make it easier on myself to see that C and see that H is I'm going to start by rewriting sine 3x so that it looks a little bit more like that general form equation. So if I write 3x as 3 times x minus 0, that's still just 3x, right? So now I can see that that h should be 0. We'll look at an example where h is not 0 here in a moment. So far, so good? Okay. But I still have a little bit of a problem here because, I have 1 over c in my formula, but I don't have a fraction here, right? Depends on what you mean by it. Well, 3 over 1 is 1/3. That's not the same thing as 3, right? But I do want to rewrite 3 as something over 1. So what happens when I do the reciprocal of a reciprocal? So like, I do the reciprocal of a reciprocal. What has happened? Did the number change? Yeah. So that's what I'm going to do here. So I'm going to do the reciprocal of the reciprocal, because that doesn't change the value of 3. It just stays 3, right? So I'm going to have 1 over 1/3. The reciprocal of the reciprocal. So what I have then is that I can see that the C is 1/3. Addie, your face tells me that you don't like what I just did. Can we talk more about it? Okay. Where did I lose you?
Just the whole fraction.
Okay.
I don't get how if it's
Okay, so it's what I'm trying to do is I want to rewrite 3 as 1 over something, right? I need 1 over something to still be 3. I observed before that if I take a number and I make its reciprocal and then make its reciprocal again, nothing has changed, right? So that's what I've did. Here, I've taken the reciprocal, so I have 1 over something. That's a reciprocal, right? And then the reciprocal of 3 is 1/3. So if I write 1 over 1/3, that's the reciprocal of the reciprocal, which is doing nothing at all to the 3. Does that make sense? And I'm going to do that every single time for my C. Owen.
Why do you need your C as a fraction? Why can't it just be
So if you defined this number in front to be C, that means when you go and make your transformation map, you'd have to make a reciprocal there. So you have to do a flip somewhere.
So you're just doing it there?
We're choosing to do it here rather than doing it out later.
Okay.
It tends to make life a little bit easier to do it here than doing it later. All right. So now that I have my values for A, C, H, and K, I can now calculate these core, or these 4 key features. So the amplitude is the absolute value of A, and A is just 2. No problem, bud. How'd it go?
I'm good.
Good. And what's the absolute value of 2? Just 2, right? Of course. Everybody's good there? Our midline, the formula for the midline is y equals k. The k value in this problem was 5. The period is 2 pi times the absolute value of c. Our c was 1/3. What's 2 pi times 1/3? Well, it'll just become 2 pi over 3, right? Did I lose anybody with how I multiplied fractions there? And the frequency is, how's that related to the period? It's the reciprocal of the period, so I'll just write that as 3 over 2 pi. We're going to do 2 more examples here doing this same process, where I'm going to add a little bit more complexity each time. On these subsequent examples, I'm going to call on people to help me answer parts. So make sure you're kind of paying attention and following along. Is there any penalty for answering something wrong? Other than being slightly embarrassed? No, there's no penalty. Okay? It's a death sentence. Yes, Julius has got it. We're going to execute you after class for every wrong answer. So some of you guys might be double dead by the end of class, which is a rough. Or does that make you alive then again? It's like multiplying 2 negatives makes a positive. If I kill you twice, do you come back to life? I don't know. We'll see, right? It's a new for me too. Is everybody ready for next example? Okay. After we do some examples of going in this direction, come on, really? Lily, what's up?
Can I do that?
Sure. Okay, so here's my next example. Who wants to volunteer to tell me the value for A? Daniel. -3. So remember, we're just thinking about this as the general equation. So we can see A is -3. Let's jump to the K next. That's the next easiest thing to get. Kara, you want to tell us that? 1 is our K. Any confusion there? All right. Who wants to be brave and try to tell us our C here?
1/1/2.
Okay. So yes, well, that's not C exactly, right, Addie? But you mean that we'd have this, right? So the C then is 1/2, right?
Oh, yeah.
So what do you notice between that coefficient on the x and the c? What is the pattern? So if I look at the coefficient on the x and the c, they are reciprocals. Excellent. Very good job, Krista. Took me a minute. I want to call you Farah for a minute. I'm like, that's your last name, not your first name. Does everybody see that? Will that always be the case? Yes. The relationship between the coefficient on the x and the value for c will always be reciprocals. Everybody feel good? Now, who can tell me the value for h? Shaw. Well, you have the sign correct, but not the correct number.
Huh?
Yeah.
Oh.
Look at the form. Look at the general form. Yeah. So we'd have to, this becomes like 2 times x minus 2. So the h is hiding there. Yes, you'd have to factor so that the leading coefficient on the x is a 1. So there might be a greatest common factor happening there, which is rough, but like, all right. Everybody see what we saw? So the h, there's 2 things we have to worry about, right? One, you have to make sure that you factored inside the parenthesis if there's any factoring that can be done, because the h might be hiding. And 2, the h is always the opposite sign that it looks like in the formula, right? Here that it says x minus 2, but the h is positive. Does everybody feel okay?
So the h we just factor out as much as possible for the greatest common factor, that's all right.
So we have to be careful here. So this time, we could the factoring was a greatest common factor. In general, the factoring you need to do makes the leading coefficient for x 1. So we'll look at an example where doing that's a little bit more complicated than a greatest common factor here in a moment. Okay?
Yeah.
So you'll see why I don't want to say yes exactly to that, but pretty close. In this case, that's exactly what happened, but it doesn't need to be that way every single time. And we'll look at an example next where that isn't the case. All right. Amplitude. Who can tell me the amplitude here? Julius. 3 is correct, just the absolute value of -3. Who can tell me the midline? Y equals 1. So I want to point out that I will be picky. The midline is the equation of a line. It needs to start y equals. If you write down 1, I will make a deduction there because you've written a number, not the equation for a line. It needs to start y equals. Fair? Okay. Again, I'm going to try to be as clear as I possibly can about like things I'll be picky about as they come up, so that you're not finding out like on the test it's like, ugh. It's like, well, we talked about this in class. You're just still, doing something else. Who can tell us the period here?
2R times absolute value.
So you mean 2 pi
Oh, yeah.
times absolute value 1 over 2, which just turns into,
2 pi over 2.
okay, which turns into pi. Mhm. And what's our frequency then? 1 over pi. So far, so good? Okay, let's do one more example. And then I think we'll say we've got it. What do you guys think? Well, I'm doing all these examples because I don't want... Well, it became clear by the time we got to the last test that I didn't do enough, and some of us clearly had some like pretty big gaps on things, so I want to make sure we're doing more example. I'm including you guys a little bit more, and I'm going a little slower to make sure that we're closer to the same spot come test time. So far, so good? Okay. All right, Lauren, what can you answer here? Let's start with A, C, H, or K. Can you give me any of those? C is not -1. Okay, Grace, what can you give me?
H is equal to -4x.
That's incorrect as well. Julius, what can you give me? A is 1. Why is that? So when we think about the general form, we're thinking about that. So A is the coefficient on the sign. There's nothing there, but we know there's always like a 1 that you can write out front. Thank you, Julius. Owen, what can you give us? C is -1 over 4. So again, we'd want to try to rewrite this in that standard form. So we do that. Okay. Again, you don't have to go in the order that I've written these. You can go in any order you want, but that is correct, Owen. Addie, what can you give us? Great. And again, we got, and then the C was, so we did that. It's always the reciprocal on the leading coefficient on the x. All right, Krista, what can you get us?
Is the line y equals -1?
That's correct. Shaw?
Each -1 pi.
You are very close. So when you factored this, you'd have that, because this, when you take the -4 out, the sign changes. So the H should be positive pi over 4. Remember, the h is always the opposite sign that it looks like in the formula, because the formula's got a minus sign in front of it. Now I'm going to pause here and ask a follow-up. Is anyone confused at where Shaw got pi over 4 from?
Yes.
Yeah.
Okay. I'm just going to scroll over and we're going to do this as like an aside. Okay. So we had negative 4x plus pi. That's what we're factoring, right?
Yeah.
So I need to make the leading coefficient of x 1. So the negative 4 is getting factored out front. Everybody agree? When I factor a greatest common factor out, what am I doing? Let's do a simpler version of this problem. What if I just do negative 4x plus 8? If I take the greatest common factor out of this, I would take out a negative 4. And what am I left with? X minus 2, right? Yeah, we're going to do it in just a second. Okay? I'm going to get there. How did the 8 turn into a negative 2? What did you do to turn 8 into negative 2? Divided by negative 4, right? So what am I going to do to turn this pi into this number here?
You would divide by negative.
Divide it by negative 4, which makes it negative, because it was positive, pi divided by 4. Krista.
Won't you only factor it if that like number that you took out can fit into both numbers?
So that's if you're doing a greatest common factor. But I can do I can factor any number out anytime I want. You just have to divide, and you might be left with a fraction. Now, we typically don't want to do that if we're factoring like a polynomial. That typically makes life not a whole lot of fun. You probably don't want to do that. Here, that's how we reveal the h. So you need to factor out whatever number makes the leading coefficient on the x 1. And if that leaves you with a fraction, that's okay. Your h is just going to be a fraction. Does that feel okay?
Yeah.
So you're right. Like typically we wouldn't want to do that, but we still could. You know, like if I add 2x minus 3, well, I could factor 2x and make that x minus 3 over 2. But typically I wouldn't want to do that, right? There's not usually anything gained by doing something like that. But it doesn't stop me from being able to do that.
Yeah.
It's just not a greatest common factor because 2 isn't a factor of 3. It's just factoring. Does that make sense?
Yeah.
Does everybody feel okay as to where the pi over 4 came from now?
Yeah.
And that made sense, right? To what we did to how to get to it. I did a good job of backtracking to like an easy example. It's like, okay, I know what to do for that. We'll just do the same thing and like I can get a fraction. Okay.
Why isn't it negative pi?
So it's not negative because in the general formula, the negative sign is there. So if I plugged in a negative pi over 4, I have minus negative pi over 4 would be a plus.
Yeah.
So you see it? Great. Yes, the absolute value of a negative is a positive. Very good.
What about for fractions? Like, is it just like, is there an absolute value for fractions, or would it just?
Sure. The absolute value of negative 1/2 is positive 1/2.
Okay, but you don't have to like solve it.
Nope, there's nothing to, there's just, all the absolute value does is destroy negative signs if they're present.
Okay.
Doesn't do anything to the fraction. The fraction part just stays the same. Gianna, we got 2 parts left. Can you tell us either the period or the frequency? You probably want to do the period first. Okay, so it's going to be 2 pi times the absolute value of negative 1/4. So that's 2 pi over 4. Can we do any better than that, though? Can we reduce that at all?
Yeah. So make it pi down to.
Excellent. And then Lily, can you give us the frequency?
Oh. 1.
So if you want to make the reciprocal, let's just flip it. Rather than writing it 1 over pi over 2.
So 2 over 5.
Yes, that's the better way of writing it. You guys feel okay doing this process?
Why did we do the amp?
Oh, we didn't do the ampli yet? Oh, my apologies. Gabby, hit us with the amplitude. 1 is correct. And just the absolute value of A.
For the period,
Yeah.
since it's the absolute value of negative 1 over 4, would it just be 2 pi times 1 over 4?
Correct, which is the 2 pi over 4, which then reduced down to pi over 2. Is that good, Addie?
2 over 5. Yeah.
And the frequency then is the reciprocal 2 over pi. Exactly, yes. What do you guys think? You can do this, right? If we have to do this in the homework? Okay. That's okay. I don't have a lot of those. The first homework set is like literally like 4 problems or something because it's asking you to do that kind of thing. What I want to do next is I want to look at the picture and pull out the values of the midline, amplitude, and period from the picture. So I've given you guys a picture here, right? I wanted to put the grid lines in. I know that makes it a little messy so that you can actually count and see things. So if I'm looking, where is the midline going to be at? So let's watch, everybody. Let's watch doing this. Because this is not a formula. I'm using my eyes to do this. So there's not like a procedure we're going to write down. You literally have to watch and see what I'm doing to understand how I'm doing this with my eyes. Everybody's okay? If I look at the maximum value here, that's 4, right? If I look at the minimum value, that's -2. If I count, there's 1, 2, 3, 4, 5, 6 units between -2 and 4. Does everybody agree? Halfway in between that is going to be 3 units up. So 1, 2, 3. That's my midline. And now if you look at it, does it look like it's the same distance from the high to the low? Yes. Should you be able to just look at it and do it with your eyes? Probably. You don't really have to write anything down. You don't have to draw the mins and maxes and circle stuff. It just has to be like right through the middle. Everybody agree? Now I'm going to find the amplitude. So if I look, the amplitude is the distance from the midline to a high or low point. So I'm going from 1 to -2. So I'm going 1, 2, 3 units. Is everybody okay there? Just counting, right? That's all I'm doing. Nothing sneaky. Last thing I'm going to do is my period. Remember, period, we're counting on the x-axis this time. So I like to start from like peak to peak. Is everybody okay there? So I'm starting at 0.5 pi and ending at 1.5 pi. How far did I go? To go from 0.25 to 1.5? 1 unit. So this would be 1 pi is my period. Is everybody okay with how I read these things from the graph? I did almost no calculation. None of it was complicated. You just had to know what you're looking at to be able to pull the values. Now, what can I say about the values for A, C, and K from the information that I found?
A is 3.
Or -3, right? Because I took the absolute value of A to get 3. The amplitude is a distance. The A could have been 3 or -3 because we take the absolute value of it, right? The midline gives me that the K is 1, and I know the period is equal to 2 pi times the absolute value of C, right?
Where do you get? Oh,
So to get the C by itself, I start by dividing both sides by 2 pi. That gives me that the C is 1, or absolute value C is 1/2, or that C could have been positive or negative C. How do you guys feel right now? Is this okay?
I'm a little confused about the period. Because why do you do 1 pi equals 2 pi?
So this is me computing the value for C. The period is 1 pi. I use the formula that period is equal to 2 pi absolute value C to solve for C. So this was 2 different steps, right? One step was I was reading the values for the amplitude, midline, and period from the graph. And then I took that information and tried to say, okay, what can I say about the values of A, C, and K for the equation of this graph? So I found out that the A could be positive or -3. We don't know which. The C could be positive or -1/2. I don't know which. But the K has to be 1. Is that okay, Addie? So it was like a 2-step thing that I did there. All right. Let me look at what I was planning on assigning here and make sure that I covered what I needed to. Seven and 8. Yeah, I'm ready to do that. Okay. All right. Okay. I need to do one more thing and then we'll be done. All right. Da, 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 da. All right. Last thing I want to do. This was something, again, that you would have done in your Algebra 2 class. We're going to rehash it right now, though. We're going to talk about the language of transformations. So there are 4 types of transformations that can occur. There's dilations, so stretches and shrinks, reflections, rotations, and then translations. 4 types of things. In this class, never talk about rotation. Okay? We can have reflections across the x or y axis. We can have translations up or down. And then we can have vertical stretches and shrinks or horizontal stretches and shrinks. They are all dictated by the coefficients A, C, H, and K. So, what I'm going to do now is I'm going to list how you can tell what type of transformation is occurring based on the values. Everybody good? Okay. Yes. Yes. You're welcome.
I seen it. I'll email you, but I did all my Delta maths, and one of my homework assignments says it was like incomplete, but I think it was because one of them like overlapped with another, so I think I didn't put the other half. Do you get what I'm like saying? Like
Maybe
It went to,
can you just give me that in the email you're gonna send me for remind me to check the Delta
Yeah.
maths?
Okay.
And I will double check whatever the thing is that you're
is
telling
it
me.
fine that I'm doing it with like a link? Also,
I prefer that we insert. Do you have a minute to sit down and pull your
Yeah.
tablet out? And we'll see if we can get that figured out.
I finished, I sent you an email, but I finished the Delta math,
Okay.
all the Delta math, and then I put in the first day assignment that.
Perfect.
and then I
That
just
sounds
have the review to finish.
that sounds great. Thank you.